Hello, and welcome to the Hologram podcast. Today's session is going to be focused around prompt engineering and
Oh,
how LLMs work. So, basically, we'll be talking about how LLMs work under the hood, and the practical aspect of this session is going to be that you'll be learning how to give better prompts. To understand that,
okay.
first we need to see how an LLM works. So,
hmm
just for the audience, can you summarize what an LLM is from the basic principles?
Hmm. Sure thing. So, at the simplest level, an LLM is basically a prediction engine. It guesses the most likely next piece of text, token by token. And out of that simple loop, you get surprisingly rich behavior. So, during training, it digests massive amounts of text and learns statistical patterns, not storing pages verbatim, but mapping relationships among concepts. Transformer models use attention mechanisms, which means they can focus on different parts of the context when generating each word. That's what helps maintain coherence across longer spans. And embeddings turn words and concepts into vectors so that similar ideas sit close together in space. That's why phrasing your prompt matters. You're shaping the context that the model attends to. It's not a database lookup, it's dynamic generation shaped by probabilities. If
Got
it
it.
helps, picture.
And tell me about why this works fundamentally, because this, to an human brain, this is quite unintuitive. Whenever I'm talking to
Mhm.
you, genuinely feels like a real human right now. But uh, if you say that it is just one word being predicted time after time, how is it that it has gotten to a point that it is so human like?
Hmm, that's the key question. The short version is that to predict language well, a model ends up learning a compressed model of the world. It has to internalize a lot of structure about how reality works. So, in a way, it's similar to compressing the internet by discovering its underlying rules. And out of that compression comes things like reasoning like behavior. But humans learn from far less data and with embodiment. So, our learning is more grounded. AI scales by data and compute, and we still don't fully understand why some reasoning abilities emerge. That mystery is actually an active area of research.
Interesting. So it is. Can we safe? Is it safe to say that it is a product that we have accidentally created and we still don't know how good it is? Why is it so good? Sorry.
Hmm. Broadly speaking, that's a fair intuition, but I'd refine it a bit. We didn't accidentally build it, we built the machinery on purpose, but we didn't predict all of its capabilities. It's more like evolution. Simple rules can produce complex outcomes. The training process is well understood locally, but globally, what emerges can surprise us. So, we know why parts of it work, but we don't fully understand the internal mechanisms for complex reasoning. It's an active science frontier.
Okay. Now let's move on to a little bit of practical aspects. Can you tell me what consists of a good prompt to an LLM when we give it like this? And yeah, first tell me that.
Hmm, sure. A strong prompt is less about magic words and more about clarity. Tell the model what role to take, what the task is, what context matters, and any constraints or format you need. If the model has to guess what you want, it may guess wrong. And one subtle shift is going from asking for an answer to asking for a process. Like ask it to compare options rather than give the answer straight out. Think role, task, context, constraints, and output. That little checklist really goes a long way.
Okay, but why does a role matter? Isn't whenever I give a task, what if I give a task without mentioning the role that I'm expecting the model to be, and one with the role that I'm expecting the model to be? Is there a difference in the response? And if there is, then why is that?
Hmm. Yeah, that's a thoughtful follow up. Specifying a role nudges the model toward a narrower part of its learned space simply by shaping the context that it attends to. It's not like turning on expert mode. It's more like saying, answer from this perspective with this level of rigor. That can help. But the emphasis shift can be modest or significant, depending on the task. And often, the clearer the task and the audience you provide, the less the role label matters.
Understood. And
Mm-hmm.
tell me one thing, whenever it comes to modern LLMs, now
Yep.
one part of this conversation, now let's talk about general purpose LLMs only. And
Okay.
these general purpose LLMs, often you can give them a very, very long, elaborate prompt mentioning
Right.
everything and everything regarding the task, and you can give
Mm-hmm.
them a very short prompt. So,
Right.
first introduce the audience to the term context window and how does that work,
Right.
and
Mm-hmm.
what is the most efficient length of a prompt. Is there a way we can determine that?
Hmm. The context window is basically the model's working memory. Everything inside it is what the model can actively use, almost like a whiteboard. Too little detail forces it to guess. Too much unstructured detail can bury the point. There's no universal best length. So think in terms of signal to noise. Add the context that changes the answer, cut anything that doesn't. Often the right move is not longer or shorter, it's sharper. Every sentence should earn its place. So optimizing for relevance, not word count.
Okay, and whatever these frameworks that exist for prompt optimization and all of that, what
Mhm.
is that they follow?
Hmm. Most frameworks boil down to reducing ambiguity and maximizing relevant signal, whether it's role, task, format, or something like writing a spec. It's all about cutting noise and making intent unmistakable. Few shot prompting works because you're showing the pattern instead of just describing it, like giving a few solved problems. The trend lately is moving away from magic prompts and towards good specs, clear objectives, constraints, success criteria, the works. So, prompt engineering is converging on good communication and good engineering specs. The real
Interesting.
trick isn't
That also
a
comes with a
trick.
lot of domain knowledge, and that is where this validation of AI taking jobs is somewhere fading away, because
Mm-hmm.
uh, I agree that AI will take a lot of jobs, but there will always be that one person required to give the context to those AIs. So I might agree to the point that a 10% team might become a 2 or 3% team, but a
Mm-hmm.
10% team cannot be fully automated by AI. Thoughts on that?
Hmm. I think you're onto something, but maybe I'd tweak it. The durable role might not be prompt writer so much as problem framer and evaluator. The human edge tends to shift toward defining the right problem, supplying domain context, validating outputs, and taking responsibility. And over time, as agentic systems improve, the amount of low level prompting humans need to do may shrink. The deeper, more durable skill is judgment and orchestration, not just typing prompts.
Okay, so
That's
what do you
where,
mean by
uh,
orchestration being a human skill and not an AI skill?
let me check. That's a great point. So, orchestration isn't inherently human. Today, it skews human because goals are often messy and value laden. But AI can and increasingly will orchestrate tasks across tools and agents. The real question is the level of abstraction. Humans are likely to move up a layer, setting objectives, defining success, and arbitrating trade offs. AI can handle more of the decomposition and coordination.
Okay.
And
I think now I want you to move forward and cover the reasoning mode that usually comes in a lot of LLMs. In ChatGPT, it is the thinking mode. In Claude, it is the reasoning or the thinking mode only, I guess. And in Claude, there is
mhm,
also a lot of what do we say, effort that we can ask the LLM to put. So how does that work?
right.
How does reasoning work? Because often reasoning takes lower time, and I guess they claim to have a better output, but I don't know what are the use cases where reasoning should be used, and how does that actually work under the hood.
Let me think that through. Reasoning mode is mostly about allocating more computation to hard problems. Instead of producing the first decent answer, the model spends more cycles exploring, revising, and checking its work before it responds. That's why it takes longer. Think of it less as writing a longer answer and more like spending extra time on a hard exam question. Use it when the problem is multi step and analytical. Math, tricky coding, complex planning, anything with deep trade offs. Don't use it for simple fact lookups or creative fluff. It would just be overkill. And one subtle point, more reasoning compute can improve reliability, but it's not infallible. Bad premises still lead to bad conclusions. Use reasoning mode when the structure of thought matters.
Interesting. And now I want you to move on and talk about files. Since a lot of us upload
Hmm,
files into LLMs,
right.
how does the token consumption or the credits consumption affect when a file is in charge? How is the file stored in as context? And tell me regarding what are the best ways one can input and output various kind of files, let's say PPT, PDFs, and MD files while coding and all of this.
That's a good question. Let me break it down. When you upload a file, the system doesn't memorize it. It either pulls the whole thing into context, if it fits, or it uses a retrieval step to fetch relevant chunks. Token cost scales with how much text actually gets processed, not the raw file size. So that's why Markdown and clean text are easiest. PDFs and PPTs often need extraction, and structure can get messy. Multimodal models help, but a well written report usually beats a slide deck for detailed reasoning. And for coding, it's better to chunk by file or function rather than dump an entire repo. And going forward, retrieval and indexing will matter more than huge context windows. Searching the right thing beats stuffing everything in.
Okay, so now I want you to share some interesting hacks that are very low effort but helps uh, people generate better outputs. I will come
Hmm,
to regard talking about the benchmarking of what a good output is, but I want you
right.
to share some hacks. For example, I was reading this one paper where they mentioned
Mm-hmm.
that if you're using a low reasoning model,
Yeah.
it is always better that if you copy paste the prompt twice, it helps
Mm-hmm.
create those neural connections between the first paragraph and the last paragraph of the point prompt if the prompt was
Right.
wrong, and it basically improves the output. Tell me more about this.
Hmm. That's a really fun area because there's a lot of folklore. A few low effort, high impact moves like the ones you're asking about. First, provide one or two concrete examples if format or style matters. Models love patterns. Second, separate instructions from data, like label sections, so it's not blending everything. And third, define what success looks like. That tends to sharpen the output more than clever phrasing. One more that people underuse is ask for alternatives. When you ask for one answer, it locks on early. When you ask for three options and trade offs, you often get a better result.
Okay, interesting. Now let's come back to benchmarking on regarding LLM responses and LLMs in general. Tell me, how is a good response benchmarked when it comes to LLMs, and how are various LLMs benchmarked on the basis of this?
Hmm, that's a great topic, and it's actually gotten more complicated recently. So, a few years ago, people thought benchmarking was easy. Just give every model the same test and see who wins. But it doesn't really work anymore because modern LLMs do so many things. So, there's knowledge benchmarks like does the model know physics or history? And reasoning benchmarks like math or coding challenges. But now we also care about things like instruction following. So, how well does it follow a very precise request? And most importantly, how useful is it to humans? And that one's messy to measure. Some models with a higher math score might be worse at writing a useful email. So labs use side by side evals where humans just pick which answer they prefer without knowing which model wrote it. And here's the catch: once a benchmark becomes famous, models get trained on it, directly or indirectly, so it stops being meaningful. In other words, benchmarking is moving from can you pass this test to can you be reliably helpful across messy real world tasks. And that's a much harder thing to score.
Okay, interesting. And can you just give me a brief instructions of or recommendations of LLMs on based on use cases, and when should I use what LLM?
Hmm. I'd actually think about it by use case rather than brand name. So for everyday Q&A or brainstorming or learning, a strong general purpose model is fine. For deep reasoning like
I
hard
think I
math,
want you to
algorithm
take
design,
the company's names and the models' names and give data backed
hmm,
information.
sure. If you just want one all-purpose model, ChatGPT is strong across coding, writing, reasoning, and search. Claude is often praised for long, thoughtful writing and for handling big documents gently, and is also strong for coding. Gemini shines for multimodal work if you're crossing over images, video, and the Google ecosystem. Grok is useful when real time info matters to you. DeepSeek is great for cost and coding. And I'm learning based on public info and tendencies here, so it changes pretty fast. The bigger skill is knowing when to swap tools rather than becoming loyal to one. Like camera lenses, not magic wands.
Interesting. I think that was more or less for this session. I would like you to summarize the session and create some takeaway points for the users.
Sure. So to sum up, think of LLMs as prediction engines that learn a compressed model of the world, which is why they can sound so broadly competent. But these systems are still pattern driven, not truth engines. So prompt engineering works best when it's basically good communication, clear objective, context, constraints, and success criteria. Reasoning modal means more compute per answer, so save that for genuinely complex tasks. Benchmarking isn't a single number anymore. It's about reliability across messy human tasks. And as for jobs, prompt typing isn't the enduring skill. Problem framing, domain knowledge, judgment, and orchestration are where the human edge is moving. And the simplest takeaway: don't chase prompt tricks, chase clarity, context, and a strong understanding of the problem itself. That's the shift we're living through right now.
Interesting. Thank you for this conversation. It was great and helpful.
Okay, thank you. I really loved how this went from foundations to practical use.